Hi again. So what we're going to do is we're going to do part 2 of the experiment. In the first part, we were looking at the difference between salty water and not so salty water to show the density differences. And we saw that dense water was extremely salty. In this experiment, we're going to look at the temperature difference. What we have in this column is ice water. So ice water is obviously going to be showing cold water. In this column, we have warm water. So at the bottom basin, we have water whose temperature is 60 degrees, and that's going to demonstrate warm water. So what we're going to do is we're going to put 2 drops of blue food coloring here, 2 drops of red food coloring here, and look at how our hot water and our cold water travel in our ocean circulation model. And I'm just stirring the column so I have my food coloring dispersed. And now we're going to put 2 drops of our red food coloring. And again, I'm just going to stir so our food coloring gets mixed. Now, if you look at our ocean circulation apparatus, you'll see that our red food coloring is staying near the top of our apparatus, and we'll see that we have red food coloring that is going in our top column. So this is to say that warm water is less dense than cold water. In warm water, our warm water particles are spread out more. And again, density is mass divided by volume. So if my water particles are more spread out, it's going to have a lower density. And we can see that our red column is completely filled with our warm water. As I was saying that, we can see our blue water has sunk to the bottom and is filling up our bottom column right here. So this is showing that cold water has a greater density than warm water. Because again, our water molecules are clumping together with cold water, so it's going to have a greater density. Now you'll notice at the top right here, you'll see that we have a layer of red that is accumulating at the top, and we have our blue sinking down lower. Again, warm water less dense, cold water more dense. And if we can actually just zoom in right down here, we'll notice that the dense water has gone across and is starting to pool at the bottom. Now, if we actually left this running for about 5 minutes, we would actually have all of our food coloring turn purple. Because when the cold water accumulates at the bottom, well, remember, there's hot water right here. What happens to cold water when I'm in the presence of warm water? It's going to heat up. So when this cold water heats up, then we can see wisps of blue already start to rise. Likewise, this red water is now in a column where it is cold. What happens when warm things are in contact with cold things? They cool down. And we can see wisps of red traveling downwards. So here we can actually see really well our ocean circulation of warm water rising, cold water falling, and then circulating around. So these are our 2 characteristics that affect ocean circulation. And it's great that we can see in our zoom right now our cold water accumulating at the bottom, warming up, and rising. Likewise, as we pan, we can see our warm water accumulating at the top, cooling, and starting to sink.